Hello, my name is Alejandro Ojeda. I'm the leader for the AESS Colombian Rover team. We're very happy to participate in this competition for the first time in our lifetimes. And finally, we've been able to gather a team from multidisciplinary disciplines like mechanic engineering, mechatronic engineering, electrical engineering, electronic engineering, and multiple disciplines around the scientific context. Now we're going to present you our SAR video, the Systematic Acceptance Review. This year we had an extra challenge for us. Due to COVID reasons, we haven't been able to gather as a team as much frequently as we would want to. Therefore, we have to make teams such like these Google Meet meetings or other type of virtual encounters to work in our projects. Anyway, you have been able to work around it for many months. As you can see, the virtual software we have been using for simulations and for designing have been the key for us to keep on with this problem. For challenges are over there for us to overcome them.
We choose rocker buggy as the suspension system of the rover. It is able to give stability and dynamics to the rover while it's driving on rough roads, but the straight arms have a disadvantage. They can block the rover when the road has high slopes or obstacles. In our rover, the rocker buggy has curved arms instead of the straight arms. These curved arms have the advantage of being able to reduce the possibility to obstruct the rover with the obstacles of the road. The rover has traction in the front and rear wheels.
We created a 3D model of the rover only with the suspension and the central bags. For test, we are going to have a dynamic simulation of the suspension with a 3D road. This road has different slopes for the test. We're going to see the dynamic simulation in isometric view and side view to see if the rover is able to pass through the road. Let's take a look.
My name is Natalia. The scientific plan of our science time is that they will use two microscopes will be used. One locates as the pattern of the rover to access characteristics of the sample to be collected, and the second will be located inside the rover to access the petri dishes that will contain the soil sample with a solution. And that identify the type of soil microorganisms that inhabit. In addition to these text, measurements of width, size, temperature, and magnetic object will be made of its sample quality through SIGs and sensor. Altair will be signed a control software.
For the control of our rover, we have decided to keep a principal system around the NVIDIA Jetson Nano. This board will help us to have all the systems connected via hardware. In here, we have the software Ubuntu 16.04, which will be running the ROS framework, especially the Kinetic King one. As you can see in the simulations, we have a rover running over our programmed navigation system. This system is based upon different methods. We are still deciding if we're going to finally use a probabilistic method or either a time elastic band approach in order to decide which are going to be the road taken in order to go through the gates on the autonomous navigation systems. As well, we are going to be using the OpenCV libraries for recognizing the images as well as the AR tags to identify different locations that are going to be milestones in the road, as well as different objects that were going to be needed in the equipment servicing mission.
Hello, my name is Joana Ramirez. I am an electronic engineer and the leader of the project management group. Regarding the planning of our rover, we hope not to exceed a budget of 18,000 US dollars, and we are accepting the security regulation for COVID issued by the Colombian government.